Hi everyone, we're excited to be here today and share with you our automated data observability and AI agents called Ella. So just to quickly introduce ourselves, my name is Or. I'm one of the co-founders here at Elementary, leading the product, and I have with me today Noah, our product lead. The agenda for today is to start with giving you all some context about Elementary. Then we will go over data reliability workflows required to implement data reliability successfully with and without. And then we will see the AI agents in action. We will show you a live demo in the product itself. So we are Elementary. We provide a data reliability platform. We have an open source data reliability and observability solution that is widely adopted, giving engineers the tools to implement data observability as part of their development workflows and in code. And we also have a cloud platform that enables also other data professionals, the entire data team, to collaborate on data quality, monitor the data, understand the data, discover the assets, and really collaborate on data reliability. These are just a few great teams that use our cloud product. We have a community of over 5,000 data engineers worldwide, coming from great companies as well. We talk to hundreds of data teams about data reliability workflows and what requires in order to implement data reliability successfully within the organization. And we divided it into the following workflows. Test coverage, which means that you need to invest in your monitors coverage. You need to make sure that you cover your data products and dependencies, and you need to understand exactly how to do that and fine-tune the monitors continuously. And this is a very important workflow to make sure that you are covered and nothing is being unmonitored, or you are able to actually see and get visibility into your data assets. Then you also need to invest in governance and to maintain that over time and to make sure that all of your assets are well governed for discovery, but also for compliance, and to make sure that there is a source of truth for your assets and everyone can rely on the same assets. Then once you start getting alerts for data incidents, you need to have a triage and response process in place to investigate those data issues. You need to invest in discovery and visibility to make sure your business teams and data consumers are independent and understand where they can find their data assets, and they have visibility into the data quality and they can trust it and rely on it. And lastly, you need to invest in monitoring the performance and optimizing your bottlenecks to make sure that your pipelines adhere to your SLAs and to make sure that you don't consume that many resources and lots of costs. These workflows are very important. You need to invest in them, put in the work, and do them continuously to implement them well in your organization. Based on our conversations, it's still really, really hard to do that. And I'm sure all of you can relate to that. This is a real lineage, true story. Imagine that you are tasked with all of these workflows in this large-scale environment. So it's really hard to implement your test coverage, to start investigating issues, to apply good governance. It's really complex in large-scale environments. I'm sure all of you can relate to that. And if we will dive to the different workflows, let's start with test coverage. So test coverage is one of the most important basic workflows that we need to implement. We need to, from that large-scale environment, understand exactly which assets need to be covered and how we should cover that. We need to fine-tune the monitors continuously. Here you can see a screenshot from our native catalog in the product that shows you the current coverage in this demo environment. And you can see that the coverage is not that good, and we have tests here and there, but it's really hard to know where we should start. This is one of the basic workflows that we wanted to infuse AI into, making it much more efficient and easier for you to implement. So let's see a quick animation, but the idea that the AI agent can actually identify which tests need to be applied based on identifying what assets are critical to me, which ones are the data products that are being queried and used by understanding the usage patterns of these data products, ultimately increasing the coverage of my data products. The AI agent is trained and optimized to go backward from these critical data products, starting by identifying them, then making sure there is a good coverage for these data products to make sure that anything that could go wrong upstream will be identified as early as possible to prevent bad data from propagating into these data products. This is done automatically by our test coverage AI agent that actually turns your coverage to be, instead of reactive and just adding coverage for the incidents that you had, being much more proactive and adding coverage for all of these critical data products and making sure the coverage is defined well across all of the different dimensions of validations that exist out there. This is why AI is very helpful, because out of this large-scale lineage and environment, it can automatically pinpoint the critical data products based on analyzing the usage and declaring the coverage backwards and trying to optimize and catch issues as early as possible. Now, let's say that we are satisfied with the new test coverage that we just built using the AI. Then we will probably, in large-scale environment, we'll start getting lots of alerts and incidents and issues continuously. And the challenge is that for each incident and data issue that we detect, we will need to follow lots of steps required to identify the root cause. This can actually take hours for just a single incident that we detected. To give you a few examples, we will need to investigate historical executions to see if this is the first time this issue has happened. We need to understand if there are any recent code changes related to that. We need to go upstream and understand if there are any related incidents on these upstream assets that can impact the current issue. We need to understand the impact of that incident and who should handle that. We need to understand if there are data changes related to that. This is extremely hard to do for each and every single incident that we receive. The AI agent can do that automatically for us by running multiple AI tools in parallel that investigate and do exactly what I've just mentioned and follow the same steps. Instead of doing that manually in hours, it can do it in near real time, basically in minutes, and provide us the suggested root cause and can actually even open a pull request that will resolve that incident if this issue is related to a code change. We are able to reduce our MTTR, our mean time to resolution, from hours to minutes. The AI is able to automate that process for us, run these tools to do the investigations in parallel, and then summarize the root cause that was identified, providing us the insight on why this incident has happened and the actual fix that can resolve it. So actually also resolving the incident automatically. This is why AI is super helpful when we need to do that triage and response workflow and implement it in our organization. Now, in terms of governance is really important. I'm sure all of you can also relate to that scenario where you have multiple somewhat similar assets that are related to the same domain or data product, and it's hard for us to understand without maintaining good governance coverage which assets we need to rely our analysis on. And also nowadays with AI, we need to make sure our data is AI ready because we want to leverage AI for analytics, AI agents for helping data consumers get insights on the data with just plain English instead of relying on SQL and complex analysis. So this is why investing in governance and monitoring the governance is really, really important. We need to fill in the gaps here. Our AI agent can actually get the context from the team and using that context, automatically identifying the gaps and then fixing them and filling in the missing metadata fields automatically by looking at our policies, understanding the context of the different data assets, the calculations that are being done there, the semantic meaning of each and every asset by understanding the names of the tables, the names of the columns, the existing descriptions, the existing posture of our metadata, and then automatically suggesting fixes for these gaps. Now, as you can see, it's much easier for us to understand which ones are internal, which ones are more publicly facing, who is responsible for these assets, and what each asset represents. This is how AI makes it much easier and even possible because in large-scale environments, taking you back to the huge lineage that we started with, doing that manually is very, very hard. And with AI, it can be done much more efficiently. Now, in terms of discovery and visibility, this is actually a scenario that I'm sure all of you can relate to. When we discussed with many data teams, we figured that although they invest in processes and tools and things like that, they still rely on each other and asking simple questions in a Slack channel like this one that says, where is the data? Actually asking discovery questions and quality questions on the data. So just giving you an example, let's say there is a data analyst that needs to calculate a metric called return on ad spend. Then it needs to understand which assets relate to that metric. Then probably the next step will be to ask the engineers. The engineers can say these are the relevant tables, but then the analysts need to understand if they can actually trust that data and if it's updated. and then they need to wait until the engineering team can reply. Now let's imagine that they are on vacation and you need to wait until they are back. This creates bottlenecks between the engineering team and the more analytical side of the data team, and also it makes the data analysts less independent and slows down the time to insight that we can provide to the business. AI can enable us to do that automatically and in self-serve because it has all the context on the data assets, the metadata that exists, the incidents that are currently in investigation and who is currently handling them. Using that context, the AI agent can actually help us answer these questions automatically, the bottleneck between the analytical side of the data team and the more technical side of the data team. And as you can see, the time to insight is much, much faster. In terms of performance, taking you back to the huge lineage, I'm sure you understand that there are multiple DAGs, and for each DAG in that huge lineage, there are different SLAs that you need to adhere to. It's very complex because you need to monitor that each DAG adheres to the SLA, then identify the bottlenecks, prioritize optimizing them, looking at each bottleneck and understanding how you can fix them by understanding the SQL code, understanding the metadata that you can pull from the data warehouse or the configuration in your dbt projects or pipelines, and it's really hard and it's not scalable. This is why AI is important, because AI can do that automatically. It can understand the SQL code. It can understand the metadata that we pull from the data warehouse. It can understand metadata from our data pipelines and then suggest a pull request that will actually optimize the query automatically and basically do it in a scalable manner for all of our bottlenecks, making our pipelines adhere to our SLAs continuously. So to summarize, we've gone through multiple workflows that are required in order for you to implement successfully data reliability in your organization. So we discussed test coverage, governance, triage and response, discovery and visibility, and performance. And all of them without AI, even if you have the insights and understand what you need to do there, you need to take actions and implement them in your case and in your environment. This is why we built an agent for each and every workflow that is how to implement, essentially to create a network of AI agents. Each agent by itself can help you implement the workflow, but then they create a network of AI agents that can collaborate with each other and share mutual memory and context, and then making your data quality and data governance improve over time automatically 24/7 and continuously without you needing to do lots of manual work. And this network is really important because they can learn from each other. I can give you an example. If the triage and response agent detected an incident and resolved it, it can store that context in the shared memory between these agents, and then the monitors coverage agent will utilize that context to suggest coverage that will prevent this incident from happening again the next time, and also making sure you have upstream coverage to catch the issues as early as possible. So it can break down all the possibilities of what can go wrong and suggest the coverage that will prevent that incident. Another example is that if the discovery agent is being questioned again and again for the same questions and there is missing metadata, then the governance agent will use that context to suggest fixes to the missing metadata in order for the discovery agent to work better and provide better results. So this network is the only way to really utilize AI in order to get the outcome of trusted data and reliable data. Now, before we will dive into the live demo and showing you the product itself, it's really top of mind for us and really important to stress out that we built it with security mindset and industry top standards. So we use AWS Bedrock with self-hosted models. All of our AI agents are opt-in and adhere to strict AI policies, and we are happy also to collaborate with your AI governance teams. And also, we keep that principle of keeping human in the loop in terms of you can still get a pull request and approve the change before the change is being merged or deployed to your environment. So you can still maintain control while automating a lot of the manual and tedious tasks behind the scenes. Okay, so we will see now a live demo. Just to give you context about the demo environment that we created, we basically use the famous Jaffle Shop project. All of you that are familiar with dbt pretty much know it already, but we tweaked it a little bit and made it go online as an e-commerce shop that sells Jaffles. Recently, we invested in marketing and we have a few use cases for our marketing efforts. Without further ado, I'll let Noah share the screen and start with showing you some use cases from the data analysis perspective.
Hey everybody, glad to be here. So now I will show you some use cases. First, let's assume that I am a data analyst in the marketing team of our Jaffel Shop company, and we lately invest in advertising. And my VP marketing asked me a dashboard to make sure that we can follow the metrics and understand that our advertising is efficient and everything is under control. Firstly, I want to understand how can I calculate the relevant data. I want to ask the AI. First, I will go into our catalog in the elementary, and I will get into our catalog AI agent. The first question that I want to ask is to understand what tables I should use for calculating the metric. And let's say I want to understand what is the return on ad spend to really understand if our advertising campaign is actually working. I will ask the agent. The agent is going to try to understand what is the related table that can help me to calculate the metric, to use it for our dashboard. First, you can understand that the relevant table is called CPA and rows, and the relevant calculation or the relevant formula is attribution revenue divided by total spend. It will show me the related tables. It will show me the upstream logic as well. And I really can understand how this data product is actually calculated and what is the relevant tables. But before I can use it, I really want to understand first that it's actually updated or if there are any issues related to the table to make sure that I can trust the data. So the second question that I will ask is to understand if for the CPA and rows table, if there is any open issues, open incidents around it. What was the last update time, for example? It will show me all the details. So I can easily see that the last update time was this morning, so I can understand the table is updated, but the score is pretty low. And I can see that we have a critical issue around column anomalies. The owner of the table is Or, so I can easily understand who to talk with. And the agent will show me that there is a critical issue on the return on ad spend column. So if, for example, I want to use this table for my dashboard, I can understand that we have several issues there that I can't use it. I can also see that the incident is acknowledged by Or, so is taken care of. And the last thing that I want to do is to make sure that I will be notified. So the last thing that I want to do is to ask the agent to add the marketing team as a subscriber. And then once Or will solve the incidents, all the marketing team will be notified. And then I can make sure that I can actually use the table for creating the dashboard. It will generate a PR for me, add the marketing team. And at the end, the PR will look like that.
Thanks, Noah. I will present from the engineering perspective how I can use the agents to solve that incident, increase the coverage, improve the metadata that is related to it, and really making sure that Noah can use the CPA and ROAS table that is important to rely your analysis on and build a dashboard for the VP marketing. So here in the incidents page, I already started looking into the incident that Noah mentioned, and I acknowledge that. You can see there is an anomaly and a drop here on the CPA and the return on ad spend column. It's a ratio between the ad spend and the revenue, and there is a sudden drop there. So I can start investigating that manually, but I can also use the AI agent to investigate the root cause for me. It will follow the same steps I would take to investigate that incident, but it will do it automatically and efficiently, much faster than I can do myself. And this way I can bring back the data and make sure it's available for Noah. You can see that it starts with showing an executive summary on the issue and what can possibly go wrong. It starts with understanding the SQL and the logic of how this metric is being calculated. But then once the agent validated the current table, it will also try to validate the upstream models if it wasn't able to identify the issue in that table. You can see that it goes upstream. Attribution touchpoint is an upstream table that impacts that CPA and ROAS table. Same for customer conversions and orders table that is upstream from the CPI and ROAS table. That, just to give you all some context, the orders table, the way that it's being calculated, it's a union between historical orders and real-time orders. The idea is we, as an e-commerce shop, get real-time orders from our website, and we have a real-time pipeline using Kafka that uploads orders into our data warehouse. We do a union between historical orders and real-time orders. The agent identified a discrepancy, and the root cause stems from a discrepancy in the amount column, because we sum the amount from the historical orders table and the real-time orders table. But let's see specifically what happened with that union between these two tables, and it seems that there is a discrepancy. This amount table is being converted between cents, and there is a missing macro here that should convert that amount column in the historical orders, because it's stored there in cents instead of dollars. And now it suggests a fix. The agent actually suggests exactly how we should fix the historical orders table. And I can even ask it to generate a pull request for us. What it will do behind the scenes is use that identified root cause, basically scan the code, clone the code, open a branch for that, and then open a pull request with a suggested fix. This way, I will be able to review that and decide if I want to merge the pull request or not. And the pull request looks as follows. As you can see, it added a missing conversion between cents to dollars. And now I can merge that, fix the problem, rerun my pipeline, and the data will be updated, and I will be able to rely error analysis on it. As you can see, it generated a PR with a summary and a few next steps. So this is how I can use the AI agent to investigate the incident on my behalf and suggesting fixes and identify the root cause automatically for me. Now, once we identify the problem, fixed it, and now I can use the data to build the analysis, I also want to make sure that next time such an incident will happen, we will catch it as early as possible and as upstream as possible. So we'll go to the catalog and ask the test recommendations AI agent to help build exactly that coverage. And again, because the agents have a mutual memory and shared context between them, now the AI test recommendations agent is aware of all the historical incidents and all the metadata and the semantic meaning of the table and the calculations being done there. And it tries to break down what could possibly go wrong that will have a significant impact on that data product, and then build a coverage for the data product. As you can see, it goes upstream, it goes to the lineage into the upstream dependencies. And based on the understanding of the recent incident and the way the metric is being calculated, it's suggested to add this column anomaly test on the amount column, which we saw that after the union between the two orders tables, there is a mismatch there is a discrepancy. So this anomaly monitor will be able to help us catching exactly the issue upstream, but also it suggests other tests that can help us prevent other incidents that could impact our most important data product. So unique to catch duplications, custom SQL test to monitor the conversion, volume and freshness test to make sure the sources are updated. Lastly, I can ask it to generate a PR for us as well. And the PR looks as follows. So you can see that it added the custom test for the conversion, the volume and freshness for the sources, and also the test that validates the column and the test amount. So with this AI agent, with just a few seconds, we were able to increase the coverage for our most critical data product. And of course, we can iterate with it, provide more context, and work together to create a very strong coverage to prevent major incidents from happening with our most critical data products. Now, let's say that I also want to change the governance and the metadata assigned to a data product and its upstream dependencies. So I can use the catalog AI to manage metadata. Because I was aware of that incident, I got a notification and started the investigation together with the AI agent, and I was also able to increase the coverage. But next time I might be on a vacation or something like that, and I don't want to be the only owner of that table, so I actually want to change myself as the owner to be the entire data engineering team. So I can get some help from the catalog AI agent to manage governance and metadata for me, and doing that automatically without me needing to do it manually. So it will go automatically upstream and traverse the lineage for me and understand exactly which models are assigned to or, and then change that to be the data engineering team without me needing to do any manual work. So let's see how it looks. It actually created a pull request for me, adding the data engineering teams as the owners of these tables. With just a few clicks, I changed all the owners upstream for my most critical data product to be the data engineering team. Now we fixed the problem, increased the test coverage, and changed the metadata and the governance for the tables related to our data product. But we also want to make sure that this data product is updated on time and adhere to our strict SLAs. And for that, we want to optimize the bottlenecks. I can immediately see that marketing ads is a bottleneck and it takes the longest. I can use the AI agent to suggest optimizations for that table. And what it will do, it will scan the code, scan the metadata from the data warehouse and the data pipeline, and suggest fixes. In this case, it suggested changing the column selections from select star to selecting specific column names, because in many columnar databases, this is inefficient. It means scanning much more data and it can impact performance. So it replaces columns to be the columns that are actually being used by understanding the downstream dependencies of that asset. It also changed the materialization to be incremental because it analyzed the time it takes for us to rebuild the table every execution, and it suggested to change that into incremental diffs instead of rebuilding the entire table from scratch every time. As you can see, it really replaced all the select stars with specific columns. Without the AI agent, I would need to do it manually by understanding which columns are being used in the downstream dependencies and then replacing the code myself. Now imagine you need to do that for all your models and all your bottlenecks and all your pipelines. So this is very, very strong. Let's summarize what we have just seen. We demonstrated how the AI agent can actually provide the data analyst, the business analyst, the more analytical side of the data team visibility in a self-serve way and making them more independent, reducing the bottleneck from the engineering team and giving them visibility into data quality itself. Then we use the AI agent to identify metadata gaps and automatically fixing them without the manual work. We also use the AI agent to investigate an incident in real time, running multiple scanners and tools in parallel to get to the root cause in minutes instead of hours, and even suggesting a PR that will fix the problem and resolve the incident, building good coverage from that critical data product to make sure nothing will fall through the cracks and we will prevent these incidents from happening again in the future. Lastly, we use the agent to optimize the queries and pipelines to adhere to our SLAs and to reduce cost and performance bottlenecks. This provides a next-gen solution because AI can help us turning observability into reliability. It means that we believe that observability is really important. It's the first step. It provides visibility. You can understand the state of your data assets. But once you have these observability insights, you need to take actions to increase the reliability of your data assets. This means fixing the problems, fixing the governance gaps, and making the data reliable. Without AI, it takes time. With AI, you can get to that state immediately and provide immediate reliability to your consumers and your organizations, and ultimately achieving high adoption in the data. This is a process that goes on because you add more assets, there is more adoption, and then you need to take these insights, turn them into actions, provide reliability, and drive adoption of the data. And the outcome of implementing these AI agents is that you are able to reduce your MTTR and downtime from hours to minutes. It helps you to solve blind spots for your critical data products. You can rest assured that your data products are covered and you know exactly what will happen. You reduce the bottleneck and basically eliminate that bottleneck between the technical teams to the analytical teams. And ideally, you provide continuous trust across the organization and drive more usage, faster insights to the entire organization. And this is why AI is really important and helpful in this. We will be happy to provide everyone a deep dive personalized demo to your use cases. So please feel free to go to our website and book a demo with us. You can also start a free trial or start a POC from our website. So welcome everyone to do that. Thank you.